Okay, geometry, we are going to move on into section 3.7, which, I got to tell you in advance, is a big section. So I'm going to break this one up into at least 2 videos, if not maybe even more than that. So in 3.7, we kind of start to draw the connection here between something that you guys have done in algebra and pre-algebra for the last couple of years and what we're doing now in geometry as we're talking about lines that are parallel and whatnot. So 3.7 is really a throwback section. What might be good news to you guys, or it might be bad depending on how you feel about it, there is really nothing new in section 3.7 that you guys didn't learn last year in Algebra 1. The downside is this is basically an entire chapter of Algebra 1 all condensed into 1 or 2 big sections here in geometry with 3.7 and 3.8. But we'll do the best we can. So the first thing we're going to be doing here as we start talking about the equations of lines in the coordinate plane is we need to go back and we need to revisit this word slope, which you guys dealt with a lot over the last couple of years, but I don't think we've talked about at all in here in geometry this year. So my kind of working definition of slope right here would be a numerical measurement of how steeply a line is rising or falling. All right, a couple of important things right there. First of all, a slope is numerical. We don't use words to describe the slope of a line, like, ooh, that's very steep, or it's not very steep. We try to use numbers because, of course, in math, we're trying to measure things quantitatively as opposed to describing them qualitatively. All right, the other thing right there, we're talking about how quickly a line is either rising or falling. So anybody who's ever been on a roof before, and a lot of people have, if I was going to ask you, were you scared up there on that roof like you were going to fall off? Some people might answer that question yes, and some people might answer that question no. And it's probably a function of how steep the roof was that you were on. So if you were on a house that had a relatively shallow pitched roof like this, and you were standing up on the side right here, you probably weren't exactly sweating bullets right there that you were going to fall off, because that roof is not very steep, so you'd probably say that the slope of that roof was pretty low, as opposed to if you were on a house that maybe looked something like this, where the roof was really steep. Now all of a sudden you would be very concerned about falling off that roof right there because the slope of that roof is much greater than the slope of the first one that we drew. So it's a question here of the degree by which that line is rising or falling. So that's going to be kind of our working definition of what slope is, everybody. And the formula here for slope, first thing we need to know, the variable that the entire world uses for slope is m. Nobody really knows the reason for that, but there's 2 things that we're going to write down here, guys. One of them is kind of an informal way of thinking about slope, and these are the 2 R words that I'm hoping you guys are familiar with, that slope is defined as the rise over run in between 2 points on a line. That's one way of thinking about it, and the more formal way of actually finding a slope, which is a numerical formula, is this expression right here, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And that's probably the more important thing for you guys to box up and make sure that you have in your notes right there. But the rise between 2 points on a line is found by the change in their y-coordinates, and subtraction is always the operation that measures change. Run, as you'll see in just a moment here, is the horizontal change between 2 points on a line segment, and so x sub 2 minus x sub 1 is the way that we measure that. So this line right here, you guys, is incredibly important, and we want to make sure that we have all of this written down carefully in our notes. Now from here, we're going to draw just a real quick kind of sketch right here of the fact that there are only 4 kinds of lines, everybody, in terms of slopes that we can draw. 4 different types, and this kind of matches all of this. Now, I went ahead and I put actual graphs here, but if I were you guys, I would just make 4 real quick, small sketches like this. Each one of those probably doesn't need to be bigger than about the size of a quarter or a golf ball, everybody, so that would work just fine. Okay, when I talk about 4 types of lines, let me show you what I mean. And no, straight is not one of the 4 types because every line is straight. The first kind of line we're going to draw is one that does this. Okay, and if we go back to our definition of slope that we wrote down earlier, slope is a numerical measurement of how steeply a line is rising or falling. So my first question for you guys is, this line that I just drew right here in blue, is that line rising or falling? Now that's actually an interesting question, because if you were standing somewhere on that line, it is both rising and falling depending on the direction that you are looking or facing or walking. Now lucky for us guys, we always read a line and its slope from left to right the same way that we read a page in a book. So from left to right, if you were standing on this little slope right here and you were traveling from left to right, that means that you would be going uphill. So what do we have here guys? This is a line that we would call a rising line. Again, it's rising because we read it from left to right. It's falling from right to left, but that's not the way that we look at it. All right, so this is a rising line, and every line that is rising has a slope that is positive. And the way in mathematics, the most efficient way of writing the word positive would be to say that your slope is greater than 0. Okay, so that's the first type of line there, one that's rising and it has a slope that's positive. You can probably now already guess the second type of line. The second type is one that's going to be going down from left to right. And this then is what we would call a falling line. Now once again, it's falling because we're reading this thing from left to right. So we're going downhill from left to right. If we were going from right to left, it would be rising, but that's not the way we look at it. And as I think you guys can probably figure out, if a rising line has a positive slope, a falling line is going to have a slope that is negative or less than 0. So those two things kind of go hand in hand. All right, guys, so that's 2 of the 4 types of lines. A line could be rising, a line could be falling. Either its slope could be positive or its slope could be negative. Well, the third type is a line that has a slope that is neither positive nor negative. And if you guys think about what we know about numbers out there, every single number in the world is either positive or negative, except for the number 0. So the third type of line we're going to draw is one that has a slope of 0. Well, if its slope is 0, it's not positive, so that line cannot be rising. And if the slope is 0, that's not negative, so the slope cannot be falling. What we're talking about then is a line that doesn't rise or fall as you move from left to right, and that would be a line that looks something like this. And instead of describing this line as rising or falling, we would describe it as a horizontal line. And the slope of a horizontal line is not positive and not negative. The slope of your horizontal line is going to have to equal exactly 0. So if you were just walking on level ground, or maybe, in the hallway at school or in your house or wherever you are, you would hope that the slope of the surface you're walking on would be 0. Okay, so that's horizontal. Now, when I talk about the fourth type of line, sometimes people get a little bit confused here. If you look at the slopes themselves, the first line we talked about had a slope that was positive. The second line had a slope that was negative. The third line had a slope that was 0. And sometimes people say, whoa, 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 that's it. There's nothing else out there. Every number is either positive or negative or 0, so there is no fourth possibility. Well, you're kind of wrong about that. What is possible is that the number doesn't exist at all. All right. Now, if you pay attention to the verbal descriptions, we said our lines were rising and then falling and then horizontal. Then people can usually remember what the last one is. The last one, everybody, would be a line that runs in this direction, and that is what we would call a vertical line. And everybody, the word vertical ends with C-A-L. A lot of people misspell that and make it C-L-E. That is not the correct spelling. And in this case, everybody, with a vertical line, for reasons we'll get into later, your slope is not positive, it's not negative, and it's not 0. What we would say in a vertical line is that your slope is undefined. And that is just another way of saying that a vertical line has no slope. And that's a really important distinction, everybody, that we need to figure out that's different here between horizontal and vertical lines. We've got to be clear here and emphasize that a horizontal line does have a slope. That slope is just 0. But a vertical line doesn't have a slope at all, again, for a reason that we'll see here relatively soon. So, everybody, as we look at these 4 together, these are the 4 types of lines that are out there. Rising lines have positive slopes. Falling lines have negative slopes. Horizontal lines have a slope of 0, and vertical lines have a slope that is undefined. And this is probably where you don't want to find yourself, everybody, because there's no way for me to draw you on this line right here without falling to your death into the abyss below you. That's probably going to hurt. All right, so those are the 4 types of lines. Okay, so let's get practical with this right here. One of the things we're going to have to do a lot of here is to try to take 2 points and find the slope of the line passing through each pair. And I want to pretend like I'm an English teacher for just a second, and I want to talk about the articles, everybody, that are in this sentence. Find the slope of the line passing through each pair of points. I didn't use an A there. I didn't say find a slope of a line. I said the for both of them. And the difference between a and the implies that there's only one here, guys. So one of the things we should know already from our studies of geometry here is that if we have 2 distinct points on the coordinate plane, there is one and only one line that passes through both of those. And that particular line only has one slope. So that's why I was able to use the in both of these cases here. All right, guys, so when they give you 2 ordered pairs here, what we could do is take the time to get a graph ready and plot them and use a ruler and draw the line between them and then count off the slope. But that's not very accurate, and it is certainly not very efficient. So what we're going to do instead is use the slope formula that we wrote down on the last page there, everybody. And that slope formula, just so we don't have to go back and look it up again, but let's write it as much as we can. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now this is probably the 3rd formula we've learned already this year that references these numbers of x1, y1, x2, and y2. We saw this same type of notation when we were using the distance formula and the midpoint formula back at the end of chapter 1. So with that in mind, everybody, here I'm just going to go through and label very quickly what these numbers are. In my first ordered pair, 5, negative 3, 5 is the first x coordinate, so that's x1. And negative 3 is the first y coordinate, so that's y1. Now as I move into the second ordered pair, its x coordinate, negative 1, is x sub 2, and then the second y coordinate, 0, is y sub 2. So those are the 4 numbers referenced by this formula here. So let's go to it, guys. Slope then is equal to y sub 2, our second y coordinate, is 0, minus y sub 1. So you always want to think subtraction, but y sub 1 here happens to be a negative number. So because it's the first time we're doing this, I'm going to write this out thoroughly. The change in y in the numerator here is 0 minus negative 3. Down in the denominator, x sub 2 is negative 1. Always think subtraction. And then x sub 1 is 5. All right, and this is something I think we're going to be able to simplify pretty quickly on our own, so let's see what happens. Up in the numerator, everybody, minus negative 3 is going to become a plus 3, and 0 plus 3 will get you a positive 3. Down on the bottom, negative 1 minus 5 is going to get you a negative 6. Now, one thing that as sophomores or juniors, a couple seniors, whatever you guys are in geometry, one thing you should know already, and you should not need to be told this by me, anytime you have a fraction, we're going to try to simplify that as much as we can. And 3 over 6, I'm really hoping you guys can just look at that and tell me that that's going to simplify into a 1/2. Now, I also want to talk about the fact that the 6 that we had there a moment ago was negative. Our slope had a positive numerator and a negative denominator. And a positive divided by a negative means that this slope is going to be negative 1/2. You've got 3 options, everybody, for where to put the negative. Most people, in a case like this, are going to leave it on the bottom because that's where the negative number was in the previous step. I get that, and that works perfectly fine. You'll get full credit for that. That said, a fraction with a positive numerator but the negative in the denominator, that's probably the least likely place you are to see it. You are more likely to see the negative up there on the number in the numerator. Okay, both of them are correct, all right? But usually you're going to see this more often than on the bottom. And the third possibility would be to carefully move that negative right there in front so that it's on exactly the same level as the fraction bar itself. Now, this is probably the best way to do it in most numerical settings, but I will say that when we're talking about slope in a way that we're going to utilize a little bit more practically here later on, it is probably more beneficial to put that negative up there in the numerator and to think of this slope as -1 over +2. Actually, you know what? We're going to go ahead and we're going to play with this right now, guys. So I'm going to pull this graph over. Now, let me be clear with you guys. We're done with this problem already. The answer, well, what did they ask us to do? Find the slope of the line passing through those points. We've got it. There's the answer of -1/2. But I haven't really illustrated to you guys what the numerical value of a slope actually indicates just yet. So let's do that right now. Now again, this is not the way you're normally going to do it. I just want to illustrate what's happening here. So our points were 5, -3. So from the origin, I go 1, 2, 3, 4, 5 to the right, and then 3 down, and that gets us, I'm going to call that point A, everybody, at 5, -3. The second point, which I will call B, is at -1, 0. So from the origin, we go left 1, and we don't move up or down at all, and that's going to be point B. So these are two distinct points located on the coordinate plane. There is one and only one line that passes through those 2 points, so I'm going to try to draw this as carefully as I can, and that line here connecting A and B is going to look something like that. I think I did a decent job of that, maybe not great. So what we have found now is that the slope of line AB is -1/2. Well, what does that actually mean? Well, if we go back and think about something we wrote down earlier, another way, another way to think about slope, the 2 R words, everybody, is rise over run. That means that to get from one point to the other, and we usually move from left to right, as I said, guys, so I'm going to talk about going from point B to point A. The way that we get from B to A is we rise, meaning we move up or down, -1 unit, and then we run, meaning we move horizontally 2 units. So let's talk about that, guys. We're going to start right over here at point B. That's where we are, and we are going to rise -1, which means we go down 1 unit. And then we're going to run 2, positive, which means we go to the right 2 units. And that's where we are now. And you will notice that green dot that I just drew is located where? On the line. Now we're not at point A yet, so we're going to repeat this process. The slope of -1/2 always means that each step we take, we go down 1, and then we go 2 to the right. Now everybody, you are not going to hear me ever say the O word that a lot of you guys say when we're talking about slope, and that's the word over. The word over is ambiguous, which means it's confusing. You can go over to the left or you can go over to the right. People don't know what that means. So we want to be directionally specific. The words up, down, left, and right, those are words that people understand directionally. Now again, where did this get us? On the line, but we're still not to point A. So again, I'm going to go down 1 unit and then right 2, and sure enough, that now gets us to our final destination here at point A. So the slope of -1/2 got us from B to A. Couple of things to point out that's also kind of interesting. Don't bother writing this down, but I told you guys a while ago that you could have put that negative number on the bottom rather than on the top. So if I had said the slope here was +1 over -2, let's think about what that means. That would kind of explain, everybody, how to get from point A to point B. Here, your rise would be +1 and your run would be -2. So from point A, a rise of +1 means up 1, and a run of -2 means left 2. Up 1, left 2, up 1, left 2, and sure enough, that's how you can get from point A to point B in 3 easy steps. And the last thing I wanted to talk about is this. If we go back and look at what the slope was originally before we simplified this, think about what happens, guys, if you started at point B and you followed this slope, 3 over negative 6. Okay? Oh, actually, better yet, if I had moved the negative up on top and made that negative 3 over 6. So a rise of negative 3 from point B would have taken me down 3 units, and then a run of 6, 1, 2, 3, 4, 5, and 6 would have gotten us to point A. But if you follow that in black, 3 over negative 6 got you from B to A in one big step, whereas the negative 1 over 2 got it to you in a couple of different ones. All right, I'm going to get rid of this junk, and I'm going to get rid of this, and I'm going to get rid of this, and I just want to make sure we understand that this is the best answer to this question, although there's a couple of different ways of interpreting what exactly that means. Last thing real quick, everybody, ask yourself, are you standing here on a line that's rising or falling or horizontal or vertical? The answer to that is it's a falling line as we read it from left to right. And we said on the previous slide that a falling line in the bottom right-hand corner here is always going to have a negative slope. And sure enough, that's what happened in this case. This was a falling line, and we ended up with a slope that was negative. All right, all right. This whole section, guys, I kind of did one example, and then if we were live in class, I was going to just be quiet and let you guys work on this one for a minute. So now would be a great time for you guys to pause the video and try example B on your own, finding the slope between these 2 points. Okay, hopefully that didn't take you too long. Let's see what's going on here for this slope. Again, the more we write the formula, you guys, the faster we're going to have it memorized. Slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So here we go. Slope is y sub 2, everybody. Our second y coordinate is this number right here, which is 3. And then minus y sub 1, the first y coordinate, which is right here. Now, rather than writing minus negative 9, which you certainly could do, I'm going to go ahead and recognize now that as soon as you see or think or you're about to write minus negative, it's faster just to change that into a positive. So you always want to think subtraction, but if you're subtracting a negative number, you can just make that addition. Down on the bottom, x sub 2, the second x coordinate is 4, minus x sub 1, the first x coordinate is negative 4. So again, minus negative 4 is just going to become a plus 4. And what happens here? That is going to give us a 12 in the numerator, an 8 in the denominator, and now we'll try to simplify this by dividing out the greatest common factor of 12 and 8, which is 4. That's going to give you a 3 on the top and a 2 on the bottom. You might be tempted to write this 3 over 2 either as a decimal, which would be 1.5, or as a mixed number, which would be 1.5. But guys, that is not how anybody in the world writes slope. It is nowhere near as helpful to us to write that slope in either of those 2 forms. So improper fractions are your friend here, everybody, when we're talking about slope. Now again, the problem is done, but let me take a quicker moment now, I hope, and see if this actually makes some sense. So the points here are negative 4, negative 9. Shoot, I'm going to run out of room here. But negative 4, 1, 2, 3, 4 to the left, and then 9 units down. Let's see, that's 6, 7, 8, 9. I'm just guessing that it's right about here, and we'll call that point A. The second point is 4, 3. So from the origin, I go 1, 2, 3, 4 to the right, 1, 2, 3 units up. This is going to be point B right here. There is only one line that passes through those 2 points, so I'm just going to eyeball that here, and let's see if this slope of 3 over 2 gets us from left to right from point A to point B. This is a little hard because I had to go off the graph itself, but a slope of 3 over 2, remember that 3 is the rise, how far we move up or down, 2 is the run, how far we move left or right. So a slope of 3 over 2 means that from point A, we're going to go up 3 units, 1, 2, 3, and to the right 2 units. I missed my line right there, but that might very well just be because I didn't do a very good job of graphing this thing by hand. Let's see if that's eventually going to get us to where we need to. I'm a little concerned, but let's try it. We keep going now. Up 3, 2 to the right. Nope, I'm still off. Up 3, 2 to the right. Still off, but up 3 and 2 to the right. Ah, there it is. And I ended up exactly where I needed to be. So what that really tells me, you guys, is that the slope was right. I just didn't do a very good job of graphing this line by hand, which really isn't that surprising, especially since we were off the graph. But that slope of 3 over 2 did in fact work to get us from point A to point B. Ask yourself again, is this line rising or falling as you read it from left to right? This is a rising line, and a rising line should always have a slope that is positive, and sure enough, that's what this one has. Let's knock out a couple more. C, -7, 3 and -7, 2. Again, if you want to pause the video and try this on your own, that would be a great idea. Okay, let's see how it goes. Slope is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1, and let's fill in what we got. All right, y sub 2, your second y coordinate is -2, minus your first y coordinate right here is 3. That's your numerator. Down in the denominator, x sub 2, your second x coordinate is -7, minus x sub 1, which is the first x coordinate, is also -7. And rather than writing minus -7, I'm going to go ahead and just change that into a +7. And now something interesting happens for the first time. -2 minus -3 gives us -5 for a numerator, but we end up with a 0 for the denominator. And what I'm hoping everybody remembers, although history tells me you might not, is that it is impossible to divide a number by 0. So what happens here, guys, is that our slope is undefined. And given that the question said find the slope of the line passing through these 2 points, this is our answer. Now, very, very quickly, everybody, let's just sketch this out one more time. You might already know what's happening here. Our first point was -7, +3. So -7, +3 would be right over here. I'll call that point A. The next point was -7, -2. This will be point B. Now, these are 2 distinct points. There is one and only one line that connects those 2. But we're saying that the slope of that line is undefined. Well, if you go back to the very first slide, what type of line did we say doesn't have a slope or has an undefined slope? That was a vertical line. And sure enough, if you take a look at this, guys, the graph certainly looks like a vertical line, which happened because your 2 x coordinates were exactly the same number. So there is a rise, everybody. To get from A to point B, we had a quote-unquote rise of -5, meaning you go down 5 units. But there was no run. You didn't move left or right at all to get from A to B. And when there's no run between your 2 points, your denominator is 0, your slope is undefined, and that guarantees that you're dealing with a vertical line. All right, and that is the last one we were going to do at this point right now. Ladies and gentlemen, I think that's probably a good place to wrap up the first part of our notes right here. So maybe give some of that homework a try and then come back to this a little bit later, and we'll see how you do. Good luck.